Okay, so today's opener is going to be a review of finding slope using rise over run and using intercepts to graph lines. So let's take a look at the first one here. So the first we have slope A. The first thing you do when you need to find the slope of a line is find your two lattice points that are closest together. The reason why you're going to find your lattice points that are closest together, that way you don't have to worry about simplifying. Now remember, lattice point is where the line intersects directly in the corner of the grid lines. So then to find your slope, you're first going to find your rise over your run. Your rise, you start from your first lattice point to the left, and you count up to your rise, which was going to be 2. Then you find your run. So then you count over 1, 2, 3 to determine what your run is. So the slope of line A is going to be 2 over 3. Okay, let's take a look at the next one. So again, the first step I'm going to do is determine my first two lattice points, or my closest two lattice points. I do this by looking at my line, and just like I read, I go from left to right. So I find my first lattice point and my second lattice point. I always start with the lattice point to the farthest left, and then I count either up or down to find my rise, and in this case I'm going to count up, meaning that it's going to be a positive, so I count up 2 spaces. So my rise is going to be 2, and then I determine my run. My run is going to be, I count over to the right, 1. So the slope, line B, is 2 over 1. Okay, let's look at an example of the slope of line C. First thing I'm going to do is identify my two lattice points, scanning it from left to right. Here's my first lattice point and my other lattice point. Now remember, those lattice points have to go directly in the corner of where that line intersects the grids. I start by finding my rise, so I start at my first lattice point. Remember, rise goes up or down. If you count up, it's going to be positive, so I'm going to go 1, 2, 3, 4, 5, 6. So my rise is 6. Then I find my run, so I count over 1. So the slope of line C is going to be 6 over 1. All right, now the slope for line D. Again, I start at the far left of my quadrant plane, and I find my first lattice point. And then I find the next closest lattice point to use, and then I go ahead and I find my slope. Now remember, rise, you can count up or down. Well, in this case, I'm going to have to go down. If I count down, it's going to be a negative number, so I go down 1. So my rise is going to be negative 1. Then my run, I count over, and it's going to be a positive 1. So the slope of line D is going to be negative 1 over 1. Now, just to remind you, I can use different lattice points throughout my line. For example, I could use this random lattice point and this random lattice point, and then I can still find my rise over my run. So in this case, my rise would be 1, 2, 3. Since I went down, it would be negative 3, and then my run would be 1, 2, 3. So then my run would be 3. But because I want it in simplest form, I would have to reduce. Both of these numbers are divisible by 3, so it would get me negative 1 over 1, which would be the same answer we have up above. That's the whole reason why we want to pick lattice points that are closest together. If you pick the two lattice points that are closest together, you won't have to worry about going back through and simplifying. Okay, so let's move on to what we took notes on over Monday and Tuesday. Determine the x-intercept and the y-intercept of the line given by the equation below. Write the ordered pairs, then graph it in the coordinate plane. The very first thing I'm going to do, so I don't forget, is go ahead and label my X and Y axis. Remember, my Y axis is the one that runs up and down, vertical, and my X axis is the line that runs left to right, which is horizontal. So when I go to determine what my y-intercept is going to be, I'm going to use the same equation to solve for both times. I'm going to start off by using x equals 0. So I'm going to substitute this first time for x. So I'm going to substitute 3 times 0, since I'm substituting for x, minus 2y equals 12. I'm going to draw my line of equality. I'm going to circle my variable, and then I'm going to solve for the variable y, which will give me my y-intercept. First thing I can do is just get rid of the 3 times 0. And then I'm going to go ahead and solve and get the y by itself. I do that by dividing by -2 on both sides. So I'm going to end up with y equals -6. So now I need to write my ordered pairs. So my x, remember, ordered pairs, you have an x first, then the y. So my ordered pair, my x value, again, is 0. Then my y value, when we solved, is -6. So my ordered pair is 0 and -6. Then I go back through and I solve again. This time, if I notice in my first box I solved for the y-intercept, this time I'm solving for the x-intercept. So up above I had x equals 0 for you. This time you need to make sure that you put down y equals 0. This time we're substituting for y. So again, I'm going to use 3x minus 2, and what do I substitute for this time? The y. So I substitute that 0 in for it, equals 12. You're going to circle your variable, draw your line of equality, and solve. We're going to go ahead and get rid of that -2 times 0, because that just pretty much cancels out. And to get the variable x by itself, we're going to divide each side by 3. So 12 divided by 3 is going to be equal to 4. So we go to write our ordered pairs. Remember, your ordered pair, the x goes first, then the y. So my x value equals 4. My y value we set up at the very beginning is going to be 0. So the x-intercept is going to be 4. Now that you've determined the ordered pairs, we're going to graph them. So I'm first going to graph my y-intercept, or the ordered pair that's 0, -6. So I start at my origin. Because the x value is 0, I stay at the origin, and my y value is -6, so I count down 6 spots. 1, 2, 3, 4, 5, 6, and I plot my line. Then I go to my next ordered pair, which is 4, 0. So I start at the origin. Because it's a positive 4, I go to the right 4 spots. And my y value is 0, so I plot it on the x-axis. I then go to graph my line, making sure that it goes through both plotted points. It goes to the edge. That was kind of sloppy. It goes to the edge of the coordinate plane here. It has an arrow on each end, and it's straight.